Okay, hi again everyone. Professor Sebastian back with our Calculus 3 class notes. I'm going to go over example 30 on page 33. We're in section 13.3. So on the previous page, I actually had already gone over how to do an arc length parameterization. Okay, so what I want to do now in this example is find the arc length parameterization of the hang glider path from the previous example. So in other words, we had that hang glider rising up along, and the path was a helix, which is r of t equals cosine of ti plus sine of tj plus tk on the interval t goes from 0 to 10. So we need to find that arc length parameter s, which remember we talked about in the previous page, is the integral from the initial base point, which for us is t equals 0. So from 0 to t of the magnitude of velocity or the speed. Now we're going to put in the dummy variable tau and integrate with respect to tau because we are integrating from 0 to t. So actually there is no dummy variable to worry about because the magnitude of the velocity came out to be square root of 2. So that's pretty easy. So integrate square root of 2 d tau. We get square root of 2 tau. Evaluated from 0 to t just means square root of 2 t. So s is the square root of 2 times t. Solving for t, I get that t then is s divided by the square root of 2. Now, what I also need to remember is that I need to say where s ranges from. So as t goes from 0 to 10, when t is 0, that means s will be 0. And when t is 10, s is 10 square root of 2. So the arc length parameterization, r of s, in other words, my parameter now is s, which represents distance along the curve, or arc length, is cosine of t, but t was s over square root of 2 in the I direction, plus sine of t, but t is s over square root of 2 in the j direction, plus tk, but t was s over square root of 2. And then I would just make sure I pointed out that s goes from 0 to 10 root 2.